And we finally made it. Here we are, the last portion of this last question 6. So we're on question 6, part C. How does the average rate of change from 40 to 80 seconds compare to the average rate of change from 90 to 110 seconds? Explain what that means in terms of the speed of the person walking. Okay, so let's do this piece by piece. Start with the 40 to 80. Let's find the average rate of change from 40 to 80. So I'm going to look at my graph. $40 to 80. So 40, let's call it 10. Let's keep our math simple here. After 40 seconds, this person walked 10 feet. And this is our first point. So on the left, we got x sub 1, and then we got y sub 1. And what's they said to 80 feet, right? 40 to 80 seconds. Yeah. So 80 seconds, my second point here. After 80 seconds, they had walked, looks like about, let's call it 13. It's halfway between 10 and 15. Looks like it might be slightly closer to 15. I'm going to call it 13. Make it simple for yourself. Don't throw decimals in there. I'm calling it 12 and a half. Let's try to keep our math as simple as possible. Now, what's this second point? It's point 2. So I've got x sub 2, comma, y sub 2 over here. Let's plug it into our formula. Change in y over change in x. On the top of my fraction, I got y sub 2 minus y sub 1. 13 minus 10. 13 minus 10. 13 minus 10. What's my formula? Y sub 2 minus y sub 1. There is my rise, my change in y. In my denominator, I've got x sub 2 minus x sub 1. My change in x, sometimes we call it the run. I personally like rise over run. Some people don't like rise over run because it's not always necessarily rising, but we could think of it as a negative rise, maybe. If it's going down, this one looks positive. We went from 10 up to 13, so we got a positive average rate of change. In my denominator, we went from 40 to 80 seconds. So we'll take 80 minus 40. 80 minus 40. Now, I put this one in green, my x sub 1, y sub 1, 40 and 10. I thought about putting that in green down here, so we could really get an idea of where these came from. Minus 10, minus 40. Look at that. In purple, I got the 80, 13. 13 is y sub 2, 80 is x sub 2, and in green, I've got 40, comma 10. 40 is x sub 1, 10 is y sub 1. Okay, so here's my average rate of change from 40 to 80. What's it all add up to? We'll put this in purple. It looks like 3 over 40. So they went 3 feet in 40 seconds. Now we're going to compare that to the 90 to 110. 90 to 110. So let's erase that stuff from the 40 to 80 so it's not getting too confusing on our graph here. I'm going to double check what they say. 90 to 110. So maybe we do this one in blue. 90 seconds. It's halfway between 80 and 100. Don't freak out if you don't see 90 on the axis. It's right there, halfway between 80 and 100. And so this point is, after 90 seconds, they had walked 15 feet. And this was x sub 1, comma, y sub 1. Now my second point is at 110. 110. 110, it's not on my axis. It's it's going to be between 100 and 120. After 110 seconds, we had walked 25 feet. There's x sub 2 comma y sub 2. So let's plug it into our formula here. Change in y over change in x. 25 minus 15, it went up 10. 25 minus 15, 25 minus 15, oh, I got an ugly 5. We went up 10, and how far do we go over to the right? 110 minus 90. X sub 2 is 110. X sub 1 is 90. 110 minus 90. Looks like we went 20 seconds to the right and up 15 feet. So we got this positive average rate of change of 10 divided by 20. Now, to really compare these two, I want to get the same denominator so I can really know what's going on. Let's go ahead and just double 10 over 20 so these can both have a denominator of 40, and I'll have a really good idea of what's going on. You could also divide 3 by a half to get 1.5, and 40 by half, divide 40 by 2 to get 20, so they could both have a denominator of 20, but I'm going to keep it as simple as possible. I'm just going to double 10 to make it 20, double 20 to make it 40. The reason I can do this, I'm multiplying by 2 over 2, so I'm not changing anything. 2 over 2 equals 1. So if you're multiplying by 2 over 2, you're not changing that fraction at all. You're just multiplying by 1, and we get 20 over 40. And so now we know that, let's grab a text box. Let's explain what this means. What's going on here? They walked 3 feet and 40 seconds from 40 to 80. 3 feet and 40 seconds from 40 to 80. So that's right here, 40 to 80. They're moving real slow right here. It's not a steep slope. They're moving real slow. They're only walking 4 feet in 40 seconds. That's pretty slow. But from 90 to 110, they walked 20 feet in 40 seconds. Or it was actually 10 feet in 20 seconds, 90 to 110. 10 feet in 20 seconds, but if we double it to get that same denominator of 40, I can see that they're going at a rate of 20 feet every 40 seconds. That's a lot faster than they were going between 40 and 80. So let's put a text box in here. We're going to describe what's going on. I know people don't like to mix writing and math, but it's super important. We need to be able to write stuff and describe what's going on in math. So I'm going to put this in maybe green, get a bigger font going so we can read it well. So the person was walking much faster. Between 90 and 110 seconds. Than they were walking between 40 and 80 seconds. So here it is. There's our different rates of change. I can see we're able to compare those two. I can see I wrote a nice sentence describing exactly what that means. We'll throw it in the bold. And there we go. That's what we're looking for on this part C of that question 6. Tell me what's going on. What does it mean that it's a steeper The average rate of change is steeper between 90 and 110 because they're walking faster than they were when they were between 40 and 80. Awesome. Study for your test. Watch the videos of the questions you're not sure about. And good luck, everybody.